Good morning to all. I am A.D.M.COLLEGE, Assistant Professor of Chemistry, A.D.M.COLLEGE for Women, Autonomous, NAGAPATTINAM. Now I am going to present my topic on food chemistry. This topic present in second MSc Chemistry. Okay, let us see that what is food chemistry? Food is the basic necessity of life. The food we eat is absorbed by our body and is used to run metabolic processes and sustain life. Food is essential for growth and various life processes. An array of food in our daily diets includes vegetables, fruits, legumes, pulses, grains, etc. All of these either consumed raw or made into delicacies and served. But nowadays, we have seen very thin milk due to mixing with water, white, yellow or black peppers in raw pulses, white tiny stones mixed with rice and so on. This mixing of elements with the food item is adulteration. Quality control measurement. Some of the other food quality control procedure include product standards, critical control point, it's a CCP, it is a identification, label specification, cleaning and sanitizing program, recall program, warehousing and shipping. Next one, what is moisture content? Moisture content influences the taste, texture, weight, appearance and life of foodstuffs. For example, substances which are too dry could affect the consistency of the end product. Conversely, excess moisture may cause food material to agglomerate or become trapped in the piping system during production. Also, the rate of microbial growth increases with the total water content, possibly resulting in spoiled stages, the need of the disposed of. However, water is also an inexpensive ingredient, adding to the weight of the final product. Obtaining an optimal analytical value for moisture is of great economic importance to the food manufacturer. For this reason, food analysis engage in the delicate balancing of moisture and total solid to ensure consistent product quality, safety and profitability. Next one, how to determine of moisture content? Okay, first one, air oven method. Moisture content of oil and fats in the loss in mass of the sample and heating at 105 plus or minus 1 degree Celsius under operating conditions specified. This is apparatus. Metal disc is 7 to 8 centimeter diameter and 2 to 3 centimeter deep, provided with tight fitting slip-on covers. Next one, this is a procedure weigh in a previously tied and tagged disc about 5 to 10 gram of oil or fat which have the thoroughly mixed by the stirring. Loosen the lid of the disc is heated in oven at the 105 plus or minus 1 degree Celsius for 1 hour. Remove the disc from the oven and close the lid. Cool in a desiccator containing phosphorus pentoxide or equivalent desiccant way. Heat in the oven for a future period of 1 hour. Cool and weigh. Repeat the process until the changes in weight between the two successive observations does not exceed 1 milligram. Carry out the determination duplicate, moisture and volatile matter. It is a formula W1 into 100 divided by W. This is a percentage by weight, where W1 means by loss in gram of the material and drying, and W is weight in gram of the material taken for test. Next one, ash content. Ash content is a measure of the total amount of minerals present within a food. Determination of ash content. The three main types of analytical procedure used to determine the ash content of foods are based on this principle. First one is dry ashing, second one is wet ashing, and the third one is a low temperature plasma dry ashing. Next one, first of all, what is preparation of the samples? This is a sample preparation. The samples of 1 to 10 gram are used in the analysis of ash content. Solid food are finally ground and then carefully mixed to facilitate the choice of the representative sample. Before carrying out an ash analysis, samples that are high in moisture are often tried to prevent patterning during the ashing. High fat samples are usually affected by the solvent extraction. As these facilities, the release of the moisture and prevent patterning. Next one. Other possible problems include the contamination of a sample by minerals in grinders, in glasswares or crucibles which come into the contact with the sample during the analysis. For some reason, it is recommended to use in ionized water when preparing samples. Next one, dry assing method. Dry assing procedure use a high temperature muffled furnace capable of maintaining temperature of between 500 to 600 degrees Celsius. Water and other volatile materials are vaporized and organic substances are burnt in the presence of the oxygen in air to carbon dioxide, water molecule and then nitrogen. Most minerals are converted to the oxide, sulfides, phosphates, chlorides or silicates. Although most of minerals have fairly low volatility at this high temperature, some are volatile and may be partially lost. Example, iron, lead and mercury. Next one, if an analysis is being carried out that determine the concentration of one of these substances, then it is advisable to use of alternative assaying method that uses of low temperatures. The food sample is weighed before and after assaying to determine the concentration of acid present. This is advantages. It is safe. Very few reagents are required. Many samples can be analyzed simultaneously, but not lab intensive. And as can be analyzed for a specific mineral content. This is disadvantages. It is a long time required. It is a time duration of 12 to 24 hours. It is a muffled furnace are quite costly to run due to the electrical cost. Lots of volatile minerals are high temperature. Example, copper, iron, lead, mercury, nickel and zinc. Recently, analytical instruments have been developed to try a sample based on microwave heating. Microwave instruments greatly reduce time required to carry out an ash analysis. With the analysis time often being less than an hour. The major disadvantages is that it is not possible to simultaneously analyze as many samples as in a muffled furnace. Next one, wet assaying method. Wet assaying is primarily used in the preparing of samples for subsequent analysis of specific minerals. It breaks down and removes the organic matrix surrounding the minerals so that they are left in the aqueous solution. A tried crowned food sample is usually weighed into a flask containing strong acid and oxidizing agent. Example, nitric, ferrochloric acid and or sulfuric acid and then heated. Heating is continuous until the organic matter is completely digested, leaving only one the mineral oxides in solution. The temperature and the time used depend on the type of acids and oxidizing agent used. Typically, a digestion takes from 10 minutes to a few hours at a temperature of about 350 degrees Celsius. The resulting solution can then be analyzed for specific minerals. Next one, this is advantages. Little loss of volatile minerals occur because of the lower temperature used, more rapid than the dry ashing. This is disadvantages. Labor intensive, require a special fume cathode if ferrochloric acid is used because of this hazardous nature. This is a low sample throughput. Next one, this is a low temperature plasma ashing method. A sample is placed into a glass chamber which is evacuated using the vacuum pump. A small amount of oxygen is pumped into the chamber and break down the nascent oxygen. This is O2 to the application of electromagnetic radio frequency field. The organic matter, the sample is rapidly oxidized by the nascent oxygen and the moisture is evaporated because of the elevated temperatures. Next one, the relatively cool temperature is less than 150 degrees Celsius used in low temperature plasma assaying cause less loss of volatile minerals than other methods. And these advantages and less change of losing trace elements by the volatilization. Next disadvantages, relatively expensive equipment and small sample throughput. Next one, very important of crude protein. Okay, let us see that crude protein. Crude protein is a measure of how much protein in your food based on laboratory tests studying the food's chemical composition. Okay, how to determine the crude proteins? The crude protein is determined by the Engel's 2-mass method. In this method, samples of known mass in combust in a high temperature, about 900 degrees Celsius, chambered in the presence of oxygen. This leads to the release of carbon dioxide, water molecule and nitrogen. The carbon dioxide and water molecules are removed by the fast cases over special columns that observe them. The nitrogen content is then measured by passing the remaining gases through a column that has a thermal conductivity detector and at the end. The column helps separate the nitrogen from the residual CO2 and H2O. This is carbon dioxide and water molecule that may have remained in the gas stream. And the instrument is calibrated by analyzing a material that is pure and has a no nitrogen concentration, such as EDTA equal 9.59% of nitrogen. Thus, the single from the thermal conductivity detector can be converted into a nitrogen content. Using suitable conversion factors which depend on the precise amino acid sequence of the protein. Advantages, it is much faster than the Jodal method, under 4 minutes per measurement compared to 1 to 2 hours for the Jodal. It does not need toxic chemicals or catalysts. Many samples can be measured automatically. It is easy to use. This is disadvantages, a high initial cost. It does not give a measure of the true protein, since all nitrogen in foods is not in from the protein. Different proteins need different correction factors because they have different amino acid sequences. The small sample size makes it difficult to obtain the representative sample. Next one, crude fiber. The crude fiber is a measure of the quantity of a indigestible cellulose. Next one, bendogens, lignin and other components of this type in present foods. It is the residual of a plant materials remaining after solvent extraction followed by the digestion and dilute acid and alkali. These compounds have a little food value but provide the bulk necessary for the proper peristaltic action in the industrial tract. Next one, determination of a crude fiber. Crude fiber method is one of the gravimetric method that measure the organic food residue remaining after sequential digestion with 0.255 normality sulfuric acid and 0.313 nitrogen sodium hydroxide solution, followed by oven drying at 104 degrees Celsius overnight and ignition in muffled furnace at 600 degrees Celsius for 3 hours. The compounds removed are predominantly protein, sugar, starch, lipids and proteins of both structural carbohydrates and lignin. In the crude fiber method, measure variable amount of the cellulose and lignin in the sample, but hemicellulose, pectins and odd gums or hydrocolloids are solubilized and removed. Therefore, crude fiber measure the tragically underestimate tightly fiber in food since it is a measure only cellulose and lignin. As a result, crude fiber method is only adequate for determination of a fiber in animals food product, but not suitable for human food analysis as lignin is specific to human health. Next one, Carbohydrate. Carbohydrate are one of the most important compounds in many foods. Carbohydrates are important in food because carbohydrates provide energy, enhance immune function of support the cellular communications. Carbohydrates are converted into energy to allow all cell or functions. There are two major types of carbohydrates, such as complex carbohydrate and simple carbohydrate. Next one, complex carbohydrates are a glycogen in human tissue and cellulose in plant tissue. Next one, how to determine of the carbohydrate. The determination of carbohydrates are several methods of carbohydrate analysis and can be divided into the physical methods and chemical methods. Physical methods generally determine some overall features, overall features of the sugars in food, such as total carbohydrates. The physical method include refractometry, polarimetry and hydrometry. Unlike physical methods, chemical methods are able to determine more specific features. For example, reducing sugar. This is experiment carbohydrates in food were determined by a different after knowing the content of other food components. The accuracy of the method defined on the determination of a other food component and it does not make any distinction between the available and non-available carbohydrates. The advantages of this method is carbohydrate content can be calculated without carry out an experiment. Next one, mineral content. It is a calcium, potassium, sodium and phosphate. Mineral content is a measure of the amount of specific inorganic compounds present within a food, such as calcium, nitrogen, potassium and phosphate. Next one, how to determine of a mineral content. The first one is sample preparation. Many of the analytical methods used to determine the specific mineral content of a food required that the mineral be divided in non-aqueous solution. For this reason, it is often necessary to isolate the minerals from the organic matrix surrounding them prior to the analysis. This is usually carried out by the asking a sample using one of the methods described in the previous section. It is important that the assaying procedure does not alter the mineral concentration in the food due to the vulcanization. Another potential source of error in mineral analysis in the presence of contamination in the water. The reagents are classware. For this reason, ultra pure water or reagent should be used and a plant should be run at the same time as the sample being analyzed. A blank uses the same classware and reagents as the sample being analyzed and therefore should contain the same concentration of any contaminants. The concentration of minerals in the blank in the subtracted from the value determined for the sample. Some substance can interface with the analysis of certain minerals. Next one is a gravimetric analysis. This is important on all the practicals. The element to be analyzed is the precipitate from solution by adding a reagent that react with it to form an insoluble complex with a known chemical formula. The precipitate is separated from the solution by filtration, rinsed, tried and weighed. The amount of mineral present in the original samples is determined from the knowledge of the chemical formula of the precipitate. For example, the amount of chloride in your solution can be determined by adding excess silver ions to form an insoluble silver chloride precipitate. Because it is known as chlorine is 24.74% of AgCl. AgCl means silver chloride. Gravimetric procedures are only suitable for larger food samples which have relatively high concentration of the mineral being analyzed. They are not suitable for analysis of a trace element because balances are not sensitive enough to accurately weigh the small amount of precipitate formed. Next one, colorimetric method. This method really on a change in a color of a reagents when it is a react with a specific mineral in the solution, which can be qualified by measuring the absorbance of the solution at a specific wavelength using a spectrometer. Colorimetric are used to determine the concentration of a wide variety of different minerals. The wanted is often used as a colorimetric reagents because it changes color when it is a react with minerals. For example, the phosphorus content of a sample can be determined by the adding the wanted molybdenate reagents to the sample, and the forms a colored complex. It is a yellow orange. It is the phosphorus which can be qualified by measuring the absorption of the solution at 420 nanometer and comparing with the calibration curve. Different reagents are also available to colorimetric determination the concentration of other minerals. And the next one is ADTA, complexometric titration. ADTA is a chemical reagents that form strong complexes with multivalent metallic ions. The disodium salt of ADTA is usually used because it is available in high purity. It is Na2H2I. The calcium content of foods is often determined by this method, and as food samples is diluted in water and the made alkaline pH is 12.5 to 13. And indicate that it can form a colored complex with ADTA is then added to the solution, and the solution is titrated with the ADTA. The ADTA indicator complex is chosen to be much higher than the ADTA mineral complex. And consequently, as long as multivalent ions remain in the solution, the ADTA forms a strong complex, but then that does not react with the indicated. However, once all the minerals ions have been complexed, any additional ADTA react with the indicator and form a colored complex that is used to determine the end point of reaction. The calcium content of a food samples is determined by the comparing the volume of ADTA required to titrate it to the end point with the calibration curve prepared from the series of solution of known calcium concentration. Next one, adulteration. Adulteration is a substance detected in other products such as food, meat, cosmetics, medicines, petrol or other chemicals which affected the quality or effectiveness of the product. Food adulteration is very usual in developing countries. The food adulteration is a process usually referred to the adding of any chemical or unwanted substance to the food that lowers the quality of food. Adulterants are mainly added to increase the quantity of food. This is performed to increase profit, but there are severe risk to human life caused by adulterant food. Some of the toxic substances are added to the food during the adulteration to increase the texture and color of the food. Some of the adulterants are extremely poisonous to the body, resulting in kidney disorders, heart failures and liver disorders, etc. And the causes of food adulteration. First one, food insecurity. To increase the quantity of a food and distribution of the nutrition. Second one, tax profit motivation. Made a portion of the business strategy. Third one is illiteracy of the general public. The lack of awareness of sufficient food composition. There is no effective food law and the lack of government initiatives. High population demands increase the food demands of the population, and it is a changing trends. Next one, type of the food adulteration. First one, intentional adulteration. It is adding adulterants initially with the purpose of increase the profit. Next one is incidental adulteration. Due to the negligence, absence of sufficient facilities, adulterations are discovered in food. Third one is a metallic adulteration. It is a purposely or accidentally adding metallic materials such as lead from water and mercury from the effluents. Next one, methods of food adulterants. First one, mixing. Mixing of clay, stones, pebbles, sand, marble chips, etc. Second one is a substitution. Cheaper and lower materials are replaced with a healthy ones completely or temporarily. Third one is a decomposed food. The decomposed ones are mixed with the healthy food, mainly the vegetables and fruits. Next one, addition of toxicant. Adding non-edible materials such as mustard oil, arginine, next preservative of a poor value coloring agent, etc. Next one, false labels are misbranding. It is changing the manufacturer and expire dates include the duplicate foodstuffs. The final, the cancelling quality, trying to hide the food stand, e.g. adds the quality food captions to lower value for sale. Next one is a commonly allergen for food. Some of the most common allergen food in India are milk and milk products, oils, sugars, food grains, and it is a product. Spices and condiments, fruits and vegetables, atta, pulses, coffee, tea, confectionery and non-alcoholic beverages, vinegar, raisins and curry powders. First one, key and better. This is allergen of vanaspati. The method of reduction. Take about 1 teaspoon of a melted ghee or butter with equal quantity concentrated hydrochloric acid in a test tube and add to it a pinch of cane sugar. Shake well for 1 minute and test it often 5 minutes. Appearance of a crimson color in lower. This is acetic layer. They show the presence of a vanaspati. Second one is milk. It is allergen of water. The method of reduction. First one, the lactometer reading should not ordinary be less than 1.026. Second method of the presence of the water can be reduced by the putting a drop of milk on a polished vertical surface. The drops of pure milk either steps or flow slowly leaving a white tile behind it. Versus milk adulterants with water will flow immediately without leaving a mark. Next one there, sweet meat, ice cream and sherbhat. The adulterant of methanol yellow or a non-permitted coal tar dye. The method of reduction. First one, extracted color with lukewarm water from food article. And add a few drops of concentration hydrochloric acid. If a magenta red color develops, the presence of a methanol yellow is indicated. Fourth one is a tar. It is adulterant of kesuretol. The methods of reduction is add 50 ml of dilute hydrochloric acids to tar and keep on simmering water for about 15 minutes. The pink color is developed indicates the presence of a kesuretol. Fifth one is here chili powder, the adulterant of stones. Method of reduction. Any thickness may be felt on tapping the sediment at the bottom of a glass. Confirm the presence of a free powder or sand. And the smooth white stew at the bottom indicated the presence of the soap stones. Next one, artificial color. Water soluble artificial dye can be deducted by a small quantity chili or a turmeric powder on the surface of water contaminate in a glass tumbler. Next one, sugar. It is allergen is salt powder. The method of reduction, dissolve in a glass of water. Salt with the settle down at the bottom. Seventh one is here turmeric. It is adulterant of colored saw test of methanol yellow. Next method of reduction. Take a teaspoonful of turmeric powder in your test. Add a few drops of concentration hydrochloric acid. Instant appearance of violet color which disappear on dilution with water. If the color